session. We are privileged to start the sessions with Peter Haumann of Jacobs University. Spice me up. What a good start. Please, the floor is yours.
Good morning, everybody, and thank you so much for this nice and funny introduction. It's really a pleasure to be here, although I see people in the audience who could do a much better job, I guess. So Marie-Françoise actually is so much of a professional since many years. So the good thing is you have lots of people around here these days that you can ask all kinds of questions. I try to bring one facet to your doors, which is about coverages, this strange and funny animal. And I'm basing this on the OGC developments. Why that? Why is that relevant for us here? Well, because INSPIRE definitions, specifications very much rely on the OGC standards. So it's good to know what's going on there in the other body. So let's see. Let's start with what we know all. We have features as kind of geographic objects, identifiable and located. Then we have a special beast here, the coverage, which has been called a space-time varying phenomenon. That sounds strange, doesn't it? Excuse me. Actually, the idea is quite simple. If you look at the polygons up there, the red polygon, let's assume it's a highway. It will always be A1 over the full length of its polygon legs. If, however, you look into this raster image, bottom right, whenever you change a location, the value will change. That is, the color, the radiosity, intensity will change. That is what it means, space-time varying. Because, by the way, it can also be time. So I have put some time series here, image time series. All of that can be subsumed under gridded data, raster data, and that is a special case of coverages. We also find point clouds and meshes there, but this is not our topic today. We have to store all these varying phenomena somehow, and it's pretty clear that they require more space than vectors. Excuse me. So actually, the coverages typically are the big geodata. Now, in INSPIRE, we find them all over the place. Ortho images, of course. Elevation data, they're also rasterized and sometimes dark. We find thematic raster layers of all kind of styles. We find weather data and whatnot. Generally, we could say it's sensor data, image data, including image time series, simulation and statistics data. So they can have space coordinates, flat. They could have height or bathymetry coordinates in addition, and also time. You find a list that has been spotted by Jordi SQU, facilitator of thematic cluster 3 in INSPIRE. So a long line of areas where we use such kind of data. Okay, INSPIRE actually, it was 2016, as a result of the last INSPIRE conference said, actually the web coverage service is the natural way to provide coverages. Sounds like a no-brainer. If it's a web coverage service, it's meant to be there for coverages. I want to talk a little bit about these today. But first, the bigger picture. How does that embed? As I said, let's look over the fence. Let's look into the Open Geospatial Consortium, where we have the coverage suite, including the web coverage service, as the big geodata standard suite. By the way, with Rasterman, with our tool, is reference implementation. But that's not the only thing. In ISO, Task Committee 211, TC211, is also working on geographic imagery, as it's called. And they are actually, they already have a standard, ISO 19123, which defines coverages in an abstract way. This is being revised currently to become 19123-1, and it will remain the abstract definition, just the principles. This is not a guidance for implementation. Many people, many implementations rely on that. You can do that, of course, but you will not necessarily be interoperable, because this is so abstract that you can find many different ways to implement it. So it has been complemented by OGC with a coverage implementation schema. The name says it already. And that is currently under adoption in ISO as 19123-2 as a companion standard. So we have the abstract and the concrete implementation guide likewise. After that, we will talk about WCS. This is going one by one just because of resource constraints. Let me draw your attention to another field that has nothing to do with the geodata initially, but which is relevant as well. Another area in ISO, the subcommittee 32 that is doing data management, has decided, we want to have something like multidimensional arrays as well. And currently, in the final stage of adoption, we find the SQL/NDA standard, which allows you to treat such data cubes just as regular elements of tables in a database, which means we can integrate data and metadata. It's another exciting story, but not our story today. And in Inspire, of course, we find coverages as well. They have been defined, and Web Coverage Service has been adopted. Why am I using this strange distinction? About 5 years back, I believe it was, where Inspire decided that we should do a little bit specific separate definitions that are not 100% aligned with OGC, and that has led to some interesting effects, let's call it like that. And so currently, Inspire, and I'm trying to make a humble contribution there from an OGC perspective, is to reharmonize that so that coverages equal OGC coverages, so Inspire equal OGC, and also with a WCS. Why that? Because we don't want to have special Inspire implementations. You want to get anything off the shelf that is a WCS, and it should do with Inspire. So there we are currently doing some final realignment steps. Why am I saying we? Just to have my coming out, I'm the editor of the coverage specifications in OGC, and I'm also heavily engaged in ISO, so that is my role in the game. Okay, coverage types. As I said, we have the abstract definition, ISO 19123, which is identical to OGC abstract topic 6, same text. And we have a concrete, so to say, coverage implementation schema. You may find it under the name GML-Cov, which is an abbreviation for GML 3.2.1 Application Schema Coverages. This is so long that I could not memorize it, so OGC was kind enough to change that into the name of Coverage Implementation Schema, which is more expressive. So it means the same. We have 1.0 since 2012, and CS 1.1 has been added recently. I will show in a minute what it does. It's an addition, it's not superseding, so anything that's 1.0 remains valid, but you can also have the concepts of 1.1. So, did I say grids, point clouds, and meshes? That's what we have here. On the right-hand side, the green thing is the raster data, so to say, the gridded data, regular or irregular. Classically, you find terms like grid coverage, rectified, and referenceable grid coverage. I always had difficulties explaining what the referenceable grid coverage is. Actually, we have combined that in 1.1, and that is a major contribution into one concept of general grids. So it's a simplification, actually. Just one way to describe grids. Okay, then we have multi-point coverages, which actually means point clouds, and the rest of the stuff on the left is what we have under general meshes. Not our concern today. We focus, so to say, on the green part. By the way, these grids are what is also known today as data cubes. A data cube is just gridded data that has more than 2 dimensions. By the way, therefore, it needs special ways to handle that efficiently. But essentially, it's gridded data with more dimensions. Okay, if you look at that from an abstract way, fortunately, it can be cast relatively simply. A coverage contains mainly a domain set. That means locations where we find values, coordinates. It contains the values, of course, that is the range set. You find the mathematical notation, right? Domain set, range set. And additionally, we have a range type that defines what the values mean. Is that radians? Is that elevation? Is that anything else? Actually, this is a point where we have not reinvented a wheel, but shamelessly stolen from our friends in the Sensor Web Enablement, and we use their way of describing the semantics. Why is that good? Because everything that a sensor observation service captures upstream can be massaged into a coverage without loss of information. That's a good thing. However, it was not enough. People wanted to have their own metadata, and so we have added a bag which can hold any kind of metadata. The coverage does not understand this because it's application dependent, but it will be carried along. So you just know that your metadata will always be associated with the coverage. By the way, that's what such a beast looks like. If you like GML, if you like angles, angle brackets, then take this one. You might see, but only if you come to the front, domain set, range set, and range type in there. You prefer JSON? Okay, then maybe this is your kind of thing. Same semantics, just a different encoding. Your web browser may prefer this one. And some people recently like the semantic web more. Okay, this unfortunately doesn't fit on the slide, so that continues down there a little bit, a few meters. But it's the same semantics. So actually we have the same representation with different encodings. This is informationally complete. It contains everything a coverage needs to have. However, it's not always what we want. And so actually, we also need to have binary encodings, which, however, don't carry all metadata. Tough luck. Therefore, these can be combined. You have a header that is maybe GML or JSON, and then files that are efficient, that are compact, that are binary. You can have tiling inside and so on. And, okay, let me skip this one. This is about the data queue part, but I would love to tell you more about that when you come to our booth. Just briefly, the right-hand side, classical way, good for horizontal processing, disastrous for vertical time series processing. Coverages allow for an efficient layout, including tiling that works across all dimensions. I know that is not enough for an explanation. Once again, out there we have a booth, and I would love to discuss that with you more. The web coverage service is the corresponding service definition now, which allows us to get such a thing from a server. Okay, if it's a petabyte, we don't want that. So we take subset, that means trimming, extracting something, or slicing, so cutting out something lower dimensional, such as, for example, time series or single images. Extensions add further functionality, and now an implementer can decide what they want to do, how much they want to invest. Just extraction, which is simple, or flexible analytics with web coverage processing service. And if you want to procure something, you simply need to enumerate the extensions that you need, and then anybody who writes a quotation knows exactly what they need to offer, so that hopefully eases communication between vendors and service operators. So I have 1 minute left, and so I don't want to scare you with this one, but you see, I could talk hours and hours about that. Don't challenge me. Hello. I knew I got it. So, European Data Cube Federation, just as a pointer, is something that is to come. Coverages, just in a nutshell, means we have a data model that I've shown, and we have a service model for space-time data, and we have conformance tests that allow to check whether a service really delivers the right thing. Convergence across standards, bodies, and implementers. By the way, if you want to see the reference implementation running out there, but I humbly admit I'm by far not the first one to talk about that. Salvatore Dali has done interesting studies way back, and that is his take on it. Thank you very much.
Thank you so much for an interesting presentation. I'm still not quite sure why this is called Inspire for Beginners. It doesn't seem that beginning. Please note your questions, and Peter will answer them later on. So the next speaker, Alejandro, please, the floor is yours, and you can right. And Alejandro will speak about why CSW Inspire compliance services are important. I am longing to be alive.
Hello, good morning. I'm going to talk about the CSW protocol, but for beginners, I think. I want to ask you, how many of you know what means CSW? Okay, about 40%. And how many of you works and use CSW? 5%? Okay. This is a good introduction. I want to boost the use of CSW. My message, I'm going to say it now and at the end, is that CSW is not just for discovering. We really need to do professional application and market applications. Okay, I'm going to talk about the catalog service for the web, the CSW protocol, just an introduction for beginners. Then we are going to try to imagine how to build an Inspire application, and then the problem, how to keep it working, and then some conclusions. Okay, according to OGC, the catalog services support how to publish and search collection of metadata. If we see that that graph that it is in the OGC document, we see in the left the heterogeneous and low domain knowledge search, which the example is Google, and one example is Google, and more homogeneous and high domain knowledge, and to explode the information, and CSW should be in that right part. We can do some operations with the CSW. There is a service there waiting for us to call and to ask questions. Some of the questions that we can say are regarding the service, the get capabilities, get record by ID, and about how to discover the data, the get records and get domain, and about exchanging information between catalogs, the transaction and harvest. From all of these, the most important ones are these three, I think. The get capabilities is the please, Mr. Catalog, tell me what you can do, what is your version, what is your languages, the encoding and that. The second one is that get record by ID. I have this reference. Can you send me the metadata of that reference? And the third one, get records. It is one operation to give you a list of registers that match specific conditions. For example, can you tell me what are the records ID that has this specific filter? For example, I don't know, protected sites or something like that. So like that, we get that IDs, and then we go to get record by ID, and we get the metadata. Okay, let's try to imagine how to build an Inspire application. Let's say that we are going to do an application for territory analysis, and we want to make it in different countries, the same application, like we will connect to 35 services, okay? WMS, WFS, but we have three different scenarios with different needs. So for one application will be 35, for another application will be another 35, so we end up with 100 connections to web services, but one of each connection is from different data providers. And just to let you know, there's about 7,000 different data providers in Europe. So it's not something that we can have it controlled really easy. For example, in Spain, there are about 97 organizations in charge of the information of the roads, just in Spain. Okay, so if we want to connect to all of them, okay, we can connect to all of them. Okay, we developed this nice application. Now I want to mention a colleague of mine. The guy is Gonzalo Lopez, and he has the 3 golden rules. He's in charge of the SDI of La Rioja. I hope you know it because of the wine. It's that one. And he's lucky, he's in charge of that SDI. And he applies these 3 golden rules to his SDI. is never change the URL of the spatial data services, because your politicians decide to change the departments, you shouldn't change the URL of your services. Okay? Don't change the name of the layers, because there are projects probably who are calling a specific layer, and if you change it, it's going to stop working. And you know what they're going to do? They will never call back again that service, because the users are going to complain. So I wanted to say that if everybody has these 3 golden rules, I mean, the applications maybe they can be a bit more stable. But they are not, and they are not because everything changed. What we cannot do is to develop an application who are using web services and think that they will never change. We are in a project, we are monitoring about 6,000 spatial data services, and between 5 and 15% of them are changing every month. And what can we change? What can change? I mean, of course, they change the URL. They just move to a cloud or a new server or whatever, or they just change the department, or they split, or stuff like that. They change the services to new versions, new server. There are a lot of changes in the services. They change the layers, they add new layers, they change the name of the layers, they change the language of the layers. What else can change? The authorization. At the beginning, everybody put the services free, and then they decide, no, let's control it. So let's put a user and password. Or you can add a token at the end of the URL, so I will know who is accessing, where, and that. So that is quite dynamic as well. Then the versions. In this application, we have the orthophoto. In this case, it's San Sebastián. And we have the orthophoto 2016, but now either they change the orthophoto of 2016 for the new one in 2017, or they add a new one, so we are not using the last one. So there is a lot of new versions of not updated services, but new versions of services. They change the style as well. You learn about a map, what the colors are and all of that, and then they change it because it's cool to have gray background, for example, and then it's like, okay, there's a change, or just to improve it because they decided to put more labels, more colors, or whatever. Another thing that changed a lot as well, and very important for the private point of view of the private companies, is the licenses. There is no license, and then there is a license, then there is a open data license, but you can use it, but not for commercial purposes and stuff like that. And those are quite dynamic as well. During the life cycle of the public administration, they decide, how to publish their data and that. So we have all of these changes. So if we got the spatial data services, we just write them down, and we put them in the app. We develop an application, and then it's there in production. We just have to sit down and wait till it will fail. It will be 1 month, it will be 2 weeks, it will be 3 months, but we cannot anticipate those changes. We have to wait, and it will fail. That's all. We sit down until some user will call us, what's this? It's not working. Or we are missing data because there is a new orthophoto, for example, and not everybody, a user will call us and will say, what's happening here? You don't have the last orthophoto. Don't worry. Wait. Either in both situations, I will go to the code, I will change the application, I will add the new layers, I will correct that slash that they changed it in the server, doing it manually, and then I send the application again through the development environment, production environment, and maybe in 1 month I will have the application tested and again working till next month, obviously. So this is without CSW. But with CSW, we change a bit the workflow in a more professional way. What we do is we go to the CSW and we get the metadata and the services from there. And we put them in the app. This allows us to track changes, because if there is a new service, it will be there in the CSW. If someone is changing something in the CSW, we can see those changes, new versions, there is a new title, a new layer, or whatever. We can track those changes very easily. And then we apply those changes. Some of them will be automatic. For example, if there is a change in the title of the map, you just, okay, thank you, there is a change. I change it in the application or in the reports, in the PDFs or whatever, and that's all. And sometimes those changes need approval. For example, there is a new data set. Do you think it's relevant for your application or not? And you add it for the application. And then automatically, without programming and changing that specifically, it will go to the application in production. So, the conclusion, as I said, CSW is needed to develop professional, up-to-date, easy-to-maintain, and high availability applications. It's much more than discover the services. Just a direct link to the spatial data services is not enough. It's going to fail. And if we have 35 or 100 of them, even more. But the CSW catalogs are not mature enough for these kind of applications, because the data providers, first they publish, and then after that they update the catalog. So they should inform about all changes through catalogs. So the applications and the people can track those changes. But there is not an easy way to discover new versions. Okay, if I have 100 catalogs, 100 registers, and there is a new one which is relevant, there is not an easy way to say, okay, there is a new orthophoto, there is a new version of this cartography or whatever. And CSW is not easy for that, but at least we have a tool there that we can just ask for the same filter, and it will tell us, it will go to that dashboard of the application manager, and we say, okay, there is a new data set. Do we apply it or not? Okay. So again, CSW is not only for discovery application, it is for develop, production, and market your applications as well. And that's all. The questions are later, so thank you very much.
Thank you very much, and very sharp timing. I do apologize about the computer to the speakers.
No, don't worry.
It's just pausing, so you just have to.
You have to touch it.
Yeah, remind me you have to fill out the form, but we can do that afterwards. So just
Okay.
we do that.
And the shift button wakes it up
Don't
again.
feel having
So
spoken.
if I do shift every 15 seconds, we might be.
That should help, yes. So do something like this on the keyboard all the time.
I'll just sort of be hectic as usual. And
So, Katharina Schleich, you will speak about DataCove, statistical.
thank you very much. Okay, so a quick overview of what I'll be presenting. A very short thing on what's DataCove. I've just started up this company since last year's Inspire conference, and also one of our principles of data ghosting, which is a nice concept we came up with. Then I'll give you a bit of information on Eurostat as a data resource. It's amazing what they make available. Then I will show you the DataCove statistical viewer we've put together in the last year. Then we'll go into a few of the tricky bits, what were all the problems encountered, and then some conclusions taken from the process of getting all of this data from Eurostat on Inspire services and in a nice end-user application. So, I mean, the overview, I mean, I'm focused on data modeling, harmonization, data provision. Real focus is actually on all of the observational data, O&M sensor web. That's been my home base in Inspire for the last 10 years. And now I decided, okay, I want to have a bit of a better overview of what the spatial stuff does, and let's see what we can do there. So, Inspire, the ghosting principle. I mean, that was, at some point I got so tired of this chicken egg problem that there are no Inspire services out there, and I know, talking with a national coordinator, one reason there aren't services is, well, nobody uses them anyway. And since nobody uses them, nobody makes services, and since there are no services, nobody uses them. And this chicken and egg problem, yes, by 2020 they will then be online hard, but then we won't know what could be better. And I've been working with environmental data for decades, so I know the IPR stuff. I know if it's available via a CC BY license, I can reprovide it as long as I properly cite it. And that's what I've been doing with various Inspire themes. You see what I have online. If somebody's interested to play with it, go to my website, they're linked from there. And so I've been, the CDDA protected site stuff has been taken from Eurostat, from EA, and yeah, various data sources across. If you want to play, go take a look. Okay, I'll do a quick overview what Eurostat has available, just because I was stunned. What is there if you know where to look for it? So it's the European Statistical Office. I mean, one thinks of demography, but it is amazing what they have. I have lost nights trawling through their database, and they have hundreds of spatial data themes, and it's all this interesting stuff I'd really like to play with, and also sort of cross-calculate how many. I mean, you have, I don't know how many applications for asylum were there per country per year. But then I'd like to see this in proportion to the populace. How can we play with that? So this really got me interested. And a lot of it is also spatial. So it refers to NUTS regions. And this would be ideal to play with. A bit of an overview of what they have. So if you go in and look Eurostat data, they have a nice browser. You can go through tables by theme. So this is, I went into the regional statistics, and you just keep folding further and further in. And like I said, a night is gone quickly. They have a nice data explorer where you can see the stuff in tabular forms. You can go in and detail more what explicitly do you want. Where what you can do here is, it took me a while to get my brain around the structure of this stratified statistical data. I was almost wondering during Peter's talk if one could do this with a coverage service, because the way it is now in Inspire, it's interesting. Because you have, for one concept, you have it split into male, female, all. You have it by age groups. So this really becomes a multidimensional data cube where exactly the coverage service ways of chopping things down are one of the bits I had to improvise on the fly. But we'll get to that later. There you can download it. You can download it in various formats. And you can also view it on their site. So you can get various tables, graphs, points. They can even do simple maps, where the problem is you always have one map per data series. So the tricky bit of saying asylum applications by population, you would then have to sit down and calculate that and do it yourself. Actually, you don't. You can play with my toy now. So the question is, what could we do if this chicken-egg problem had somehow been resolved and something were there? So last fall, I set up Inspire services first for the vector statistical units. There I chose the NUTS regions, again, all available at Eurostat. The only tricky bit was transforming it, shoving it in there. And then for the themes, actually it's population distribution. I should have caught that. But I pulled down 23 different statistical measures. They're all linked with the NUTS regions, and made it available via Inspire. And one of the backgrounds to this was last December we had Danube Hack 2.0. This was a beautiful geospatial data hackathon we held in Bratislava for the Central European region. And so I thought, to date has always been, is there a shapefile somewhere that I can hack, and trying to also get the kids who are learning geospatial development to say, look, this is your future. Learn this now, and by the time you're done with school, you can get a job because somebody might need this. And so I had this online, and it was one of the different projects we did, where it ended up we didn't get done. It got done, I think, the Danube Hack was early December. It was finally really running sometime in February. And you'll get the details a bit later in this presentation. So I'll do a quick run through of what we have. So, I mean, you can download one you can select what measure do you want. Here right now, I mean, what I'm presenting here was too late at night, it makes no sense, but we've got the hospital beds by NUTS2 regions, so you select your statistic. Then you have various subclassifications. So here it's classified into psychiatric care, curative care, long-term, other, rehabilitation, or just available. So this you can use to subsample it, and you can select a year and your unit. Then you say get data set, and you have that presented. Right now I just have a simple scale from green to blue showing the differences. And this again also shows the problem, because if you have the available beds in hospitals, oh gee, Germany probably has more than most of Central Europe because it has the population of the rest of Central Europe. So that makes it a bit more difficult to understand. That's why you need these relativation bits. You can see it right now in a table. So you have all of the, on the left side, you've got the NUTS region, and then you've got the number, and you've got the NUTS region again. So to show the further calculation bit, I now said, okay, let's also take the health personnel by NUTS regions, get that data set, and now the open calculator button comes. And that's the fun bit where you can then say, do this calculation. I mean, right now I'm calculating the number of hospital beds divided by the health personnel. But it could also it could mean something if I knew what I was doing, for if I knew anything about health. And I mean, it's a quick and dirty hack, but it's easy to do. You say the various layers you have each get a letter, and you can put in a simple algebraic formula, A divided by B, and you get the first data flow divided by the second data flow. And there you suddenly get a different structure. Suddenly you see that the relation of hospital beds to personnel shifts quite interesting towards Eastern Europe. So I'm not sure if it's good or bad right now. Details you can play with, but that's the principles behind it. And now for at least what for me as a tech geek is the interesting part, how did we get from statistical data at Eurostat and knowledge of Inspire to make this application? So the technology is for the service provisions is all done with GeoServer, and the data transformation I actually did with little Java hacks, because the format provided by the EA, by Eurostat, I cannot see any standard transformation tool unpacking this packed, stratified, classified. But I got it into the database and got services online a bit. And the viewer, we used open layers and then Ajax jQuery, quick and dirty, but nice to use. But there were still several bits missing and problems along the way. So, I mean, the first problem was the initial query, what statistics are available? I mean, if I'm working directly on a database, I take the table of statistics, I do a select distinct on the statistical measure. Doesn't exist. Inspire in general does not have standardized queries. So, I mean, if you have it open, you can create your own stored query. If you really know how, where comes the next tricky bit? It's not documented anywhere how to do stored queries for complex features. And it's subtly different from the stored queries for simple features. I finally figured it out by looking at the Finnish services which worked. I've been requested by GeoServer to put this into the documentation, so hopefully it'll be there soon. But what we needed for this viewer was a list, what is the statistical measures available. Then we would actually like to have, for a statistical measure, what are the classification axes and possible values. So do I classify by gender? Do I classify by age? If I classify by age, what are the age ranges I have? Because I could go to the code list, but if I go to the Eurostat code, age classification code list, there are hundreds of entries, and the data set will only have a handful. So these were all stored queries, which I ended up then implementing. Since I was also directly on the database, I could first set up these various views and things to do additional tables, which then had a list of statistical measures, or then also had the measure I could get the list of all measures, the list of classifications per measure, and then also the feature IDs for the feature which were selected by the user. Okay, and then the second trick was there's so much data packed in there. I mean, it's basically a coverage like Peter was presenting. You have, for each NUTS region, you have the data by gender, let's say, so you've got male and female and all, and then you've got it by 1 year age group. So that's, again, 100 values. So you have 300 values for each geometry object. And I'm sure there are applications which can use this, but for my viewer, I can only display one number per polygon. So why should I push all of this data to my simple client? I mean, I had 12 megabyte features, and it wasn't the geometry. The geometry was trivial. 12 megabyte were classified data. And how can I filter that? So this is sort of a quick and dirty sketch of the architecture. And what we did is I developed a little on-the-fly middleware to filter out the classifications I want. That I got the user to say, okay, I want the number of hospital beds in psychiatric hospitals. I figured out which features have that. And I didn't request this information directly from the GeoServer. I sent this request to my little filter middleware, say, give me these features, but only this extract. That would then do the query all on the server, get the 12 megabytes, slice that down to the little bit which I wanted, and then to make my life even easier, I did an on-the-fly transformation to JSON, because this is just so much nicer to deal with in a web application, not to have to worry about all of the clunky XML. So these are all of the little tricky bits which I'm right now missing in Inspire. I mean, the standardized stored queries would be nice, and also little enabling bits in between would make people's lives so much easier. Okay, here's a bit more information on the filter middleware. I've explained that. It's there for general reference. So you can go through and say, give me the 5-year-old females, and you get 1 point for the polygon and not 300. Implemented in PHP. Here you've got the description of how it works. If somebody wants to play with it right now, I still have a bit of a funky URI. This will be sorted shortly. Okay, problems encountered. First problem was that the formulation of stored queries for complex features, you can find specification how to query on a bounding box or on something spatial, but there's nowhere documented how you do the XPath for the stored query for complex features. I actually, for this implementation, I then took it down to simple features and made stored queries on that. And what I see as an absolute deficit of the web feature service is the lack of something like a select distinct. I mean, the closest I can do, there's a call, I keep forgetting what the name is, get property value. You can basically chop a complex feature down to just one element. But again, if the server has 1,000 features, you then get 1,000 entries, and you get to figure out how many times you have one word written there and basically push that together yourself. So how feature service has gotten this far without that, I don't know. Another tricky bit was it turns out that GeoServer has problems providing a web map service on a multi-service surface. There we again said, okay, pragmatic, took it down to a simple feature, served that, proof of concept. And one of the final bits, which had me chasing my tail for nights, is it actually turns out that if one requests multiple features from GeoServer with one request, it works beautifully the first time and the second time and maybe up to 4 times. And then the GeoServer comes into a state where you can get simple features and you can get map service, and the complex features just don't exist. No response. And you then have to restart GeoServer. There's actually then a follow-up error that all the database connections stay, so if you do this a few times, you can't even restart it. Has all been input back to OSGeo. They're aware of this. Hopefully something will change. So insights for Inspire. What I'm missing in all of this is some sort of real pragmatic fitness for use checks. That was one of my rationales for doing this, is just seeing, is this just a nice idea, or can we really do something with this? We'll need to include some real use cases and usability checks because, like I said, things that I can't filter a distinct value for an attribute makes it basically unusable. Standardized stored queries would be very valuable. There's one standardized stored query to get a data set in Inspire. There isn't even a stored query to get a feature by its Inspire ID. And how people are supposed to access the data, or I mean, all of that is, we had that talk yesterday. And a final insight is that the population distribution structure, it's right now an uneasy mix between sort of an Excel sheet creatively broken down into an XML structure, and the more I think about it, the more I think it should actually be a coverage. So something would ideally change there. Conclusions, more and more data is available online. Show something, thank you. But very little of it is harmonized, which is essential for reuse because most of the time was spent figuring out the Eurostat formats. The Inspire data specifications are a good start, but quite difficult to implement with the current technology. We're missing standardized stored queries. Some real live examples would be good. I mean, this is also something which I've been pushing on the Inspire clusters. I facilitate the observational environmental monitoring facilities cluster. Nobody dares show what they have because they're afraid that it isn't perfect, and therefore there are no examples, and therefore nobody asks because they're scared that their example might be worse. Please share what you have. Nobody's example is perfect. I do not know if there is one officially valid Inspire service in Europe right now. So just dare show what you have, share what you have. That's the only way that we can help each other get things running. Fitness for use should be further analyzed. And this would make things like My Little Toy quite possible. Thank you.
Thank you. I always like when other sectors, as we call them, us few nerds, other sectors tell us, could we work closer together? I have to estimate on that. So, last but not least, Daniela, you would take the floor, please. And you find the presentation? Yes, that's good. And remember, we have the questions. You stay to the questions. I have thought some very, very sharp ones up if you like them. But I'm sure you have a lot of questions to ask us. So data quality management, you feel?
Yes.
Nice.
Good morning, everyone. My name is Daniela Dogan. I'm survey engineer, and I work for European Environment Agency on data reporting. So I spent the last 15 years working with spatial data on large scale, like topographic and cadastral maps, using mainly the desktop component of CAD or GIS application. So today I'm going to speak a bit about the data quality, and as you most probably already know, the Inspire technical guidelines mentioned the standard ISO 19157, named Geographical Information Data Quality, to describe the quality of spatial teams. So as you can see, there are 6 elements and also sub-elements of the data quality mentioned by the ISO standard. I'm not going to give you the definition of every element or sub-elements. If you want to know more about all these data quality elements and sub-elements, you simply have to open the data specification for a given spatial team, like for example Annex 1 protective size, and read chapter 7 named data quality. So in this slide I would like to show you a kind of map of all data quality elements and sub-elements recommended and required by Inspire. You can see across the top all the ISO standard, all the ISO data elements and sub-elements, and also down the left side you can see all the spatial themes. So I was surprised about this, let's say, map, because I can see that the main pressure, let's say pressure, is on the conceptual consistency sub-elements and also on the domain consistency. So I will give the same example because it's very easy to understand. Protected size. You can see actually that Inspire Technical Guidelines ask for 5 sub-elements. 2 for completeness. Sorry. 2 for completeness, 2 for logical consistency, and 1 for position accuracy. So in ISO standard, data quality is expressed or described by data quality elements, 1 or more data quality elements. And if you want to describe one data quality element, for example, you have to choose 1 or more data quality measures, or we can say tests, or in EA we are calling checks. And then you have to perform a data quality evaluation, you will get some results, and after that you can describe all these data quality elements using metadata, or even more, using a standalone quality report. So the standalone quality report actually is not replaced. What I would like to say is actually the standard quality report does not replace the metadata, but instead provide more information about the quality. So if we open the data specification protected size, we have chapter 7, data quality. We can see the main data quality sub-elements. We can find also some minimum data quality requirements and some recommendations. Okay. We also have some definition for every data quality elements that is recommended or and required. You can see also the minimum data quality requirements or acceptance criteria or conformance quality level. This is the expression used by the ISO standard. For protected sites, we don't have minimum data quality requirements and also no recommendation, general recommendation. If we would like to see more about one sub-element, for example, completeness omission, you can see here the let's say the template for a measure. So the name of the measure or the actually check should be performed on your data sets, it's called rate of missing item. So if you want to check the rate of missing item, you should express all these results as error rate. And what I forgot to say is that when you say rate of missing item, actually cover fields, records, values, features, and sometimes even files in the data sets. I think, for example, the shapefile format, sometimes you forgot to provide the project file, the information regarding the coordinate reference system. So once again, So once again, for data quality element, we discuss about the completeness with the sub-element omission. We describe the measure or the checks, name, rate of missing item. And on the data quality evaluation results, we don't have any recommendation. What happened in EA? So the core data flows in EA has 4 stages. The first stage is when we have to define the guidelines for reporting obligation. Then we have to define the XML schemas. Then we have to define the database schemas. And for all these XML schemas and database schemas, we have to define also the quality control checks, which actually are the data quality measures. but they are not actually the standard measure, are, let's say, user-defined measures. And actually in this stage, we define actually what we want to get, or what we would like to see. In stage 2, which actually is covered by the ReportNet, we run some automatic quality checks, and we'll see in the next slide a short example of an automatic quality report, which is actually get by the member state. And the third stage, named European Data Integration, we are performing some automatic and manual quality checks. And even in the last stage, we also continue to perform some automatic and manual quality checks. And actually in the stage 3 and 4, we already know what are the results of the data quality. Sometimes we are calling a posteriori data quality. So a priori data quality requirements start in stage 1, what we want. And in the last stage, 3 and 4, we get the results that are usually documented in metadata, and sometimes for some core data flows are documented in a standalone data quality report. This is an example of an automatic quality report. It's for CDDA. As you can see, there are 9 quality tests. We are calling tests. And here, in my opinion, all these 9 data quality tests are equivalent to measure in ISO standard. If we like to see more on the mandatory value, let's take the first example. We actually, on the mandatory value, we like to check the presence of mandatory elements. You have a couple of fields. And actually, these tests cover more than one checks. I mean, this check, mandatory value, it's applied for different fields of the data set. But also we have some restriction. For example, geographical coordinates are mandatory if, for example, CDDA coordinate code is different from 2. So there are also some restriction. So let's try to create a link between the EEA, let's say, quality checks and INSPIRE requirements. So on the left, you can see the requirements in INSPIRE. So in my opinion, for the mandatory value, this is the link with the element completeness and sub-element omission. And for the mandatory value, the user-defined data quality measure is all the records must have the site code field. So this is the equivalent to the standardized measure rate of missing item. And as a minimum data quality requirements in, for example, for protected sites, we don't have any minimum data quality requirements, but instead we have. So for the conformance test, we consider the acceptance criteria like 0 error in the data set. Last year, we started a project named Data Quality Rule Register. It's more an exploratory project, and we try to define a list of standardized but also user-defined data quality measures. The idea is just to have a common, let's say, common basket with all data quality checks / measures in ISO, which could be reused for different core data flows and even more across different production stage in EA. So we see this data quality rule register as having 3 layers. First one is actually the existing data quality checks in EA, and then we are going to define a second layer named rules, which actually are equivalent to the measure in ISO. And then for these rules, we like to define also the corresponding elements and sub-elements in ISO. So what I would like to say here for this project, there are also some hidden advantage of this project, and I have some notes here just to make sure I didn't forget them. And for example, we like to avoid over-engineering quality control process, and also to identify which are the uncovered area across the EA regarding the data quality requirements. So this is actually another schema of the register of quality rules. So this register we like to be a kind of bridge between what is actually running in EA and the ISO standard. So we don't want to interfere too much on the data quality checks, but at least to create a link with the ISO standard. These are my questions, just to make sure I will get some questions. Maybe we'll discuss later. And as a conclusion, regarding the data specification, I think they are not very restrictive on the data quality. For example, for the elements that should be covered, for the measure that should be applied on the data sets, or, for example, they are not restrictive sometimes on the minimum data quality requirements. What we could improve, for example, have a consistent approach in defining data quality elements and measures across different annexes and or teams. For example, for Annex 3, as you can see, we don't have any, let's say, recommendation or requirements on topological consistency and temporal consistency. Regarding the EA quality assurance quality controller flow, in my opinion, we already covered all the, let's say, we cover the minimum INSPIRE requirements on data quality in our core data flows, but we like to cover new components and to cover and also to improve. And here's an example: absolute position accuracy. We should improve this all these checks. And data quality rule register would like to promote the interoperability of the data quality by proposing a common criteria to categorize data quality across EA production stage, and also harmonize data quality terminology across different core data flows. As you can see, for the same concept, we say record uniqueness, duplicate elements, duplicate entries, duplicate values. So we have to choose one of them and use the same language across different core data flows and across EA production stage. We like also to assign and link the existing data quality checks to ISO quality elements and sub-elements, and also harmonize the standalone data quality reports. Thank you.
Thank you so much. So now I would like to invite all the speakers up here, and please give them a hand while they transfer themselves. Excellent presentation. And we have a microphone, isn't that right? Yes. So I will start by asking you to participate. You must have some questions. It was very interesting and not that beginner-ish presentation. So please, pose a question. Yes. You will have a microphone because it's here for all of us to see it. And if you could just briefly state your name and where you come from.
Okay, my name is Vincent Bars. I'm from Belgium. I have a question for Alejandro. I think that the service embeds some metadata. Do you use this in the monitoring of the service to make changes in your apps, or you only use CSW?
Yes, I mean the service is an index of metadata. So you have to ask the catalog service, you get the metadata, and then you process the metadata.
Okay, but for example, the WMS have a section with some metadata. There is an abstract and maybe a date. Do you use also this information?
Not really, because that is not really implemented yet. I mean, sometimes you have metadata inside the services, but they are not coherent with the metadata that are stored in the CSW. I mean, the CSW will be really important, but they are not mature enough yet in that way.
Thank you.
Any more? Yes.
Hello, Ina de Visser, Genova in the Netherlands. I have a question to Daniela. It's not clear to me if the tooling for the quality checks is running at the EEA, or is it also available for the member states to provide checks themselves?
Both.
Okay.
That was a fast question answer. That's fine. Any more? Do you have any questions for each other? Something that you thought about? Yes?
Yes, I
Daniela.
have some
And use the
questions, some
microphone,
burning
please.
questions.
Yeah.
So, I need your help and your opinion about those two data quality checks which are running in EA for different core data flows. So, first one, minimum mapping units, this minimum requirement. You have the definition, but when I have to create a link or to add a label on the existing check, a label that points to the ISO standard, what do you think? Actually, this check refer to the topological consistency or conceptual consistency?
Well, and the audience
Yes.
can participate as well. that might be a...
This is not a tricky question. I mean, it's a real
is.
problem. Yes. And the second one, there is another data quality check in the specification. You have the definition C34 coordinates accuracy, and they ask for 4 decimal places. And in my opinion, the number of decimal places for decimal degrees coordinates is not the accuracy. It's actually the precision or resolution. So I give an example about the precision or resolution. There is a rule there. And on the right side, you have not, so I said not absolute accuracy. So then, what is the right elements and sub-elements? Logical consistency / conceptual consistency, or format consistency. Conceptual and format are both under logical consistency.
So if I'm getting you
Anybody?
right,
Yes.
this
Please use the
positional,
microphone, please.
if I'm getting you right, this positional accuracy, the red part, means that I can have 10 digits in the coordinate, but it's just at the wrong place. Is that correct? Okay. So in this case, I believe it doesn't have to do with a conceptual consistency. Yes, I'm coming from a database world. So we model data, we draw diagrams that make up a schema, entity relationship diagrams, UML, and so on. And this is what the model, the brain of the database is. I would say that this is an input error. This is something that might be captured by an extra attribute. If you say, I don't trust this value, but it's not a conceptual inconsistency from my perspective. But I may be wrong. I'm just saying what comes to my mind after seeing this for 10 seconds.
Are there any other bits? Yeah? You need the microphone, please.
Onur Link from Turkey. For the coordinate accuracy, I would like to make a comment. Actually, as you have mentioned, it must not be an uncertainty or internal precision or internal consistency of the data set. It is something different from the accuracy. The internal, the precision is something related with the data involved itself. It is the dispersion value to its expected value in the terms of statistics, you know. But the accuracy is something distance between the ground truth value and the their observational, actually after the adjustments of the observations, you got one value, which has been defined here.
Yes. So what is your opinion? We should change from coordinate accuracy to coordinate precision? Because actually this was my initial proposal,
Well,
to change the coordinate.
It's another question. I just commented between the accuracy, difference of the dispersional, internal accuracy, precision, and the accuracy. These are two different issues, actually, in the statistics, as you know.
With the general problem, it tends to be subsumed as scale. And I mean, I've had so many people ask me, what is the scale of your WFS?
Yeah. 1 to 20.
Nobody.
One more question for Daniel.
Sure, absolutely. Go ahead.
Do you have any feedbacks after the checks have been filled down? Do you define feedback to the data providers or the?
Yes, the feedback is also provided in the data quality report, automatic data quality report.
Maybe you can do
all
that
the
afterwards.
information.
Yeah, you can kind of connect over coffee, I guess.
Thank you.
Thank you. Yes, please.
Sorry, to respond to the question number 2, we might better respond to the question number 1 first, in fact, because accuracy and precision will be related to the minimal mapping unit, to the scale.
Usually we define these minimum mapping units when we have to express the geometry. But here you actually provide some coordinates in the attribute table. So
I'm sure that you will be available after this session, so you can keep on discussing, because there's some good bits and you can actually have something. I have a question for you, Katarina. You demonstrated use of Inspire data in the health sector, for instance, via statistics. If you could have granted one big wish in the Inspire community, what would that be?
For this topic or general?
No, for what you showed us.
In that case, if it's for I'd say basically the standardized stored queries.
Mm-hmm.
I mean, reworking the PD theme could also make sense, but the stored queries go across everything. And one of my big worries is we'll have beautiful data online and it'll be impossible to access.
Yes. And how do we come about that?
At the end of the day, we need to push the various MIG representatives to say this would need to be extended to the data specifications, because, I mean, some of it is generic. Get feature by Inspire identifier, all themes should have. But a lot of it, for each theme, you'll have specific elements where you know this is what people are looking for. And for me, this should be actually added to the data specification. That one then says, okay, with the population distribution, we would need an additional filter on the statistical measure. If we could somehow get that added in the follow-up rounds, where, I mean, the good news is things are starting to happen to make Inspire A simpler and B more usable. So the more people who can somehow make a push in this direction and say this would be a useful waste of commission funds. Maybe the expert groups, which will be set up in the next months, can also get the mandate to do this and make Inspire usable for all.
Okay, we will pressure, will we? More questions? I have one for Peter. This extended schema, if you should point out one wow feature, what is the real value thing here of the extended schema?
Over the last half year or so, a new term has come up that is called analysis-ready data. Let's bring the data into a shape that they are useful for the users. We have experience in that since long because we are doing seamless map. When we go to Google Maps, we see one Earth. We don't see a million of individual files. We can extend this concept, for example, into time. Why not build up time series into one object so that I don't have a zillion of different files, but I have one object? This is just one example for analysis ready. But in the end, it's a task for the providers of data to provide data in a way that are useful. Now the experts will say, but wait a moment, I have overlaps and I cannot lose these pixels. You know what? Most applications couldn't care less about this. And I believe that there is a contribution in the coverages concept in getting data analysis ready, and that is simpler to use for those ones who did not study geography, geodetics, or something like that.
Thank you. Thank you. I will keep you the last 2 minutes because then we have done our deals. So do you have any further questions? Any problems that we should solve now we're here? Daniela, do you have more problems? Oh, I won't ask you because you will say yes. Are you happy? Has it been a good session? Then please applaud the presentation. And you will be the first in the coffee line. Go out there.
And I would like to say a big thank you to Ulla for this really nice moderation and for guiding everything so fantastically.